torque, power, relation between the torque and the power, then comes the function of the transmission. So transmission is again a big subject, so that will be a different video again. And let me see these three as of now. Okay, so let me go ahead. And torque. So what is torque? Torque is actually a twisting force. Torque is a rotational force that tends to cause a rotation. Torque can be calculated by multiplying the amount of the force with the distance from the center. It is measured in Newton meters, so or kgm, that is kilograms per meter. And this is how it is. So torque is equal to 0.5 meter into 20 kgs will be 10 kgm. This is how it is calculated. Example, so this is the center point of the nut or the bolt. This is a spanner or a wrench. What happens here is when we fix the spanner to the bolt or the nut, if it is a small spanner which is somewhere from the center point of the from the nut till the end point of the spanner, if it is half meter, there we give somewhere in a high pressure of 20 kgs. For example, imagine when we have double the size. For example, this is a 1 meter. So 1 meter 10 kg is very much equal to this half meter of 20 kgs pressure. Okay, so that's how this works. So same like that, we have torque coming out from the engine. So the crankshaft will give out a torque. There is a twist force. So at the crankshaft, what is the torque? You would have seen these brochures, right? So saying the engine displacement is 2.4 liter or 2496 cc, 4-cylinder, so inline engine, all those. So down you can see one thing called the power and the torque. So that torque is this, the engine's crankshaft, which gives you a power output of 200 newton meters, is something like that. Example, this is a 1 meter of the range. If it is 10 kgs at the end, right? So whatever you are giving the pressure, so that 10 kgs will be somewhere around 100 newton meters. So when we convert it 100 newton meters, here is 1 kgm is equal to 9.807 newton meters, and if it is 1 newton meter, it will be equal to 0.1020 kg. So this is how the value of it. But this twist force will be available here. So center point of the crankshaft, whatever the power is taken out, so it's measured in that part. The torque which comes out of the engine will be taken from the crankshaft. From there it will be the transmission. From the transmission to the differential and the wheels, so that how much the torque is given out and the wheel rotates so that the vehicle moves. So torque developed by the engine. Okay. So when you are in a workshop or a manufacturing unit, this is how it works. So there is something called the torque wrench. There will be one digital display here which shows you what is the torque of that particular nut or the bolt what we are tightening it. We can't over tighten it. We can't make it loose also, because when the vehicles are used, right? So after some time the nuts or the bolts can become more looser. So what is mentioned as a torque in their service manual or the manufacturing instruction manual, it should be the same as that. So you would have seen some marks there, right? From the bolt till on the nut till the body, there'll be marks in many of the cars. If you see yellow color, the green color, the blue color, something like that. So that makes sure that's the torque and it is marked there. So if the nut is loosened, those line marks will be having variation, so that those nuts or the bolts are loosened. It means that. And at the time of service, when you are removing the bolt or the nut and you're tightening it, right? So that's the last turn, it has to come and match up to this. So it cannot go beyond this or lesser than that. So if it is more beyond, so that the nut or the bolt can get misthreading or it can snap out. So to avoid that, this is the torque which is mentioned has to be given only up to that. So sometimes it is hard when you're using a smaller spanner to tighten it up to that torque, but it will be easier for you to use a bigger one, the double the size of the smaller spanner. The bigger one can be used, whereas the smaller one, when you use 20 kg of the pressure at the end, but the same longer spanner at the same point, you can give only 10 kgs. That's more than enough, which will be equal of the 20 kgs of the half meter spanner. So torque developed by the engine. So the engine also develops the torque. There is a turning force or the twist force which helps to move the vehicle. In simpler terms, the torque is defined as a pulling force and varies with the engine speed. So you know that the graphs is like that. So this is the torque or the power, and this is the engine's RPM. If it is flat torque, graph going up like this and flattening it there and getting it down. but the power then rises up till the peak point and then gets down. So that's how it is designed. And here, varying with the engine speed, the torque actually varies. So, for example, if you are between 1600 to 2600 rpm, you get a flat torque up to 200 newton meters. So, there you get the power. A high torque at low engine speed gives pulling power to engine and easy drivability. So, that's what it means here. And so, next will be the high torque fab statement or the fab table. Here we have the high torque. So, vehicle can be driven in higher gears with lower engine RPM. So, benefits are that better fuel efficiency, longer engine life, lower maintenance cost of the engine. That's what it is. So when the engine is running at a lower RPM, so you get a better fuel efficiency. You don't have to rev it higher to burn it more, and more better engine life. So we are not running till the deadline, and lower maintenance cost of the engine. Yes, it is sure. Then comes the lesser gear changes, lesser engine gear shifts. So that is lesser gear changes, so that less tiring for the driver and easy to drive in the congested city traffic. And I made a spelling mistake here, congested and SITY. My sincere apologies for that.